We had started with your matrices, then we went to types of matrices, and then we went into Cayley-Hamilton theorem. So your Cayley-Hamilton theorem statement, everyone knows it, isn't it? Every square matrix satisfies its own characteristic equation. In that, your characteristic equation general format will be your modulus of A minus lambda I. This is your general formula, okay, to find out your characteristic equation. Whereas for a 2 cross 2, if you are using the formula, what will be the formula? It will be lambda square minus S1 lambda plus S2 equal to 0. You have to definitely remember this formula, okay, for a 2 cross 2. For a 3 cross 3, it will be lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. You have to know what is this S1. S1 is the sum of the main diagonal elements. S2 is determinant of A. For a 3 cross 3, S1 is the sum of the main diagonal elements. S2 is the sum of the minus of the main diagonal elements. S3 is your determinant. So this definitely you have to know, because without knowing the characteristic equation, you cannot find out anything. Okay. After finding out the characteristic equation only, you will substitute instead of lambda A and check whether it is satisfying. If it is a square matrix, definitely it will satisfy. That will be your Cayley-Hamilton theorem. Okay, it is satisfying Cayley-Hamilton theorem. So till this we have finished. Okay, and we have done a lot of problems in your Cayley-Hamilton theorem. Next, we will go on to finding out your eigenvalues and eigenvectors. Before going into your eigenvalues and eigenvectors, what and all you'll have to know in this. You have to know whether the given matrix is a symmetric matrix or not a symmetric matrix. Okay, that is your main aim which you have to see in your given matrix. And then what you have to know is you have to know how to find out your characteristic equation. So you have to know your 2 cross 2 matrix means what is your characteristic equation, 3 cross 3 means what is your characteristic equation. After finding out your characteristic equation, you have to solve that characteristic equation. How do you solve? You know how to solve your quadratic equation. No. You would have done in your 11th and 12th. You would have been given an equation in x square plus 4x plus 2 is equal to 0. Solve that equation, they will ask you. The same way you will solve it here. Okay, there instead of x, you will be having here lambda. Okay, you will solve it, get the values of lambda. That will become your eigenvalues. Okay, eigenvectors I will tell you when we do the problem. Okay? So first write the heading as symmetric matrix. So first we will write what is the symmetric matrix. Put today's date and write today's 3. Write the heading as symmetric matrix. Anyone knows what is symmetric matrix? What is symmetric matrix? Do you remember? If you don't know in definition, at least in problem, give me an example. What is symmetric matrix? Don't know. Okay, we'll write the definition, then I will give you the example. So it will also be a square matrix. A square matrix. Right? A square matrix A is equal to Aij. Your given matrix Aij is said to be symmetric. Is said to be symmetric. Said to be symmetric if Aij is equal to Aj. If Aij is equal to Aj for all your Ij. For all Ij. So for this, and write it as a note. A is said to be symmetric. A is said to be symmetric. A is said to be symmetric if A is equal to A transpose. Even if you change your rows and columns, you will get the same matrix. Means it is a symmetric matrix. Okay. So I will take the example as like this. A is equal to, I've got A, H, G, H, B, F, G, F, and C. Okay. So this is your given matrix. Your given matrix is this. So you will see whether it is symmetric or not by taking your A transpose. Okay. Your A transpose, if you see, you will take your columns into rows and your rows into columns. Okay. So we will take your rows into columns. So it will be A, H, G. Again, your second row, H, B, F. Third row, G, F, and C. A good example of your symmetric matrix. See, the same given matrix we are getting it in A transpose. Okay, so if it is equal, it is a symmetric matrix. If it is not equal, it will become a non-symmetric. Basically, what is it is main diagonal elements you will take. No, the main diagonal elements will vary. The above term and the below term will be the same. PHF, HF. If it is like that, it is the same. You all finished writing?
Yes, ma'am.
So in the next heading, right, non-symmetric matrix. So this is an example for your symmetric matrix. Right? Next, you write non-symmetric matrix. Non okay. If this is not equal to your ji, then it is called a non-symmetric. Okay, so A is said to be your non-symmetric if your A is not equal to A transpose. If it is not equal, then it is a non-symmetric matrix. So for a non-symmetric matrix, I will write in numbers. So the values are -2, 2, -3, 2, 1, -6, -1, -2, 0. Okay. One easier method is you'll see your diagonal elements top and bottom. If it is the same, it is the symmetric matrix. If it is not same, it is non-symmetric. But if they're asking in the question, check whether it is a symmetric or a non-symmetric matrix. You have to find out your A transpose. Okay, you find out your A transpose. For your A transpose, you have one. Okay, so when you do it, you will take your row to column. So it will become -2, 2, -3. Second row is 2, 1, -6, -1, -2. So here, if you see your given matrix is not equal to your transpose, then it is not equal, it is a non-symmetric. Non-symmetric. Next, we will go on to eigenvalues. Are we all finished?
Yes,
This
ma'am.
eigenvalues can also be called as latent values. Okay? Eigenvalues, or this is also called as latent. Also called as latent values. That definition also we will write it down. Let A be a square matrix. Let A be a square matrix of order. Square matrix of order n cross n cross n. The characteristic equation. You know your characteristic equation, no? Write that one. Characteristic equation general is A minus lambda I equal to 0. Okay, for a 2 cross 2 matrices, what is your formula? Write that formula. I will write just the formula. You write the expansion also. Okay. Lambda square minus S1 lambda plus S2 equal to 0, where your S1 is your sum of the main diagonal elements, S2 is your determinant of A. Write it down. Okay. Write all your expansion also. For a 3 cross 3 matrix, your formula will be lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. You have to write your expansion also. Okay, so this will be the characteristic equation. After finding out the characteristic equation, you will solve. Okay, you will solve and find out the roots. The roots of the characteristic equation. The roots of the characteristic equation. Roots of the characteristic equation are called your eigenvalues. Called eigenvalues. So write it down. So first you'll have to know what is your eigenvalue. So what you have to do, you have to find out for your square matrix, you find out your characteristic equation. The characteristic equation is a 2 cross 2 matrix, this will be the formula. 3 cross 3, this is your formula. After finding out your characteristic equation, you will solve that characteristic equation. That will become the roots. Okay, that roots only we will be calling as your eigenvalues. Okay. Next will be your eigenvector. You have to know what is your eigenvector. Right? What is your eigenvector? Let A be a right? A be a square matrix. Let A square matrix. Let A be a square matrix of order n cross n. Order n cross n. It has to be a square matrix, so it will be n cross n. Here also take it as n cross n. Cannot be n cross n. The square matrix. Okay, so it will be n cross n. So let A be a square matrix of order n cross n. If there exists a non-zero vector, a non-zero vector, that non-zero vector we will take it as x. non-zero vector x such that your ax is equal to lambda x. You do the problem such that ax is equal to lambda x. Then your x is called the eigenvector. It's called the eigenvector. Responding to the eigenvalue, responding to the eigenvalue lambda. This lambda is only your eigenvalue. Okay, that is what you will be finding out. Okay, after finding out that lambda value, you will substitute it in this non-zero vector x. Okay, whatever value you've got, that you will substitute it here, get your eigenvector. Okay, that's all. So we will do problems related with this. Find out your eigenvalue and eigenvector. Just finish writing. Tell me so that we will start with the problems. You finish writing?
Yes, ma'am. Start with 3 cross 3 matrix. The question: find the eigenvalue and eigenvector. Find the eigenvalue and eigenvector. Eigenvalues and eigenvectors of the matrix A is equal to, your given matrix is 1, 0, minus 1, 2, 1, 2, 2. Okay, so this is your given matrix. So in your given matrix, first step is to see whether it is a symmetric matrix or a non-symmetric. That you will do. Okay. So this is your given matrix. Is it a symmetric matrix or non-symmetric matrix? What is a symmetric matrix? What is a non-symmetric? Symmetric matrix means you have to see in your diagonal element above and below. Okay, if the values are the same, or if you're able to find out your A transpose, if both are equal. Okay, if both are equal, then it is a symmetric matrix. If it is not equal, then it is a non-symmetric matrix. Now, this is a symmetric matrix or non-symmetric? Non-symmetric matrix.
Okay. So first step is to write that the given matrix is not a, it is a non-symmetric matrix. So it is a non-symmetric matrix. That will be your first step. So you'll write this is a non-symmetric matrix. Okay, after that, find out your characteristic equation. Okay, as how you find out your characteristic equation, find your characteristic equation. So this is a 3 cross 3 equation. So for your characteristic equation, the formula will be lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Okay, so this will be your characteristic equation. Find out your S1, S2 and S3. Find out your characteristic. What is your S1?
5.
Yes.
6.
6. Very good. S1 is 6. You're adding the diagonal elements. 1 plus 2 plus 3 is 6. Very good. Find out your S2. S2 is your sum of the main diagonal elements. S2, 1, 2, 3 plus 1 minus 1, 2, 3 plus then 1, 0, 1, 2. So what is your S2? What is it? What is your S2?
7.
7 years ago. Very good. Why are you taking so much of time? You have to do it really very fast. Okay, that is 6 minus 2, which is 4. 3 minus 2, which is 1, 2. Okay, so you're getting your S2 to be 7. Everyone got it? 7. Yeah. Similarly, find out your S3. S3 is your determinant of A. Find out your S3. So S3. You got 7 or 11? What was your S2? Did you get 11? Yeah, what did you get your S2? Here it is 3 minus of minus, so it will become plus. Are you getting S2 to be 11? Find out your S3. You're all doing, isn't it? What is your S3? Want me to do it? Just gonna find the determinant of this. So it will be 1 into 6 minus 2 minus 0. So 0, 0 to become. Then you have got your minus 1 into 2 minus 4. Okay. 0 with anything will become 0. So you'll be having 4. Here 1 minus 2 plus 2 which should become S3 is equal to 6. Why you're all doing it very slowly? Do it very fast, then only you'll be able to finish it. I've told you so many times. Are you getting S3 to be 6? Yes? Yes or no? What happened? BSc. Tell me, are you getting this S3 to be 6?
Yes.
Why are you? You're getting, Now substitute it in this equation. See, you're getting your S1 6, S2 11, and S3 is equal to 6. Substitute it in this equation. When you substitute it in that equation, what is the equation you're getting?
Lambda 3
I will
minus
rub.
6 square plus 11 lambda minus.
Very good. Minus 6 lambda square plus 11 lambda minus 6 equal to 0. Okay, ma'am. So we have got this equation. I will rub this. Rub this.
Yes, ma'am.
Yeah. So we have found out your characteristic equation. Okay, after finding out your characteristic equation, now we are going to find out your eigenvalue. Okay, how to find out your eigenvalue? Since it is lambda cube, you have to find out three eigenvalues. Okay, you have to find out three roots for this. That is, you have to find out your lambda. Okay, lambda's values for this equation. So how do you find out how do you find out the roots? One is directly you have to find out the by solving it. Okay, this solving can be done by a long division method. Okay, or your synthetic division also. So I will try out with your synthetic division. So what I will do is I will start with the problem. I think you will all remember. Okay. So I will start with your coefficient of your lambda cube. So I'm taking it as 1. Coefficient of your lambda square is -6. Coefficient of your lambda plus 11. And then your constant term, which is -6. So what I do is I have to check with what value I get the last term to be 0. Okay, if I make it to be 0, then what does it imply? This, whatever value we are taking it here, that value is the root of this equation. Root is nothing but that value, if you substitute it here, that will become equal to 0. Okay, so whatever value you're substituting here, okay, you will have to start it with 1. Okay, we will start it with 1. So I'm putting 1 here. As I've taken 1, here your elementary will be, you will have to put 0 only and add it. So 1 plus 0, it is 1. 1 into 1, it is 1. Listen, you would have done it already. Okay, the same thing I am also doing, the synthetic division. So 1 into 1 is 1. -6 plus 1, which will become -5. Okay, now 1 into -5 is -5. 11 minus 5 is 6. 1 into 6 is 6. And here it becomes 0. So since the last term becomes 0, now lambda is equal to 1 is one of the root. Okay, lambda is equal to 1. We have put 1 here and we have tried, and the last term is becomes 0. Now the remaining values, here you've got 1 minus 5, 6, isn't it? That since we have already taken one root, the remaining value here you will write it as lambda square. Okay, 1 I've written here, coefficient that will become 1 minus 5 lambda plus 6 is equal to 0. Okay, so I'm trying to solve this equation. I'm doing it by a synthetic division. I started with putting it 1. As soon as I gave your last value to be 0, then it implies that that is the root. Okay, that is the root of this equation. Root is nothing but when you substitute this 1 here. Okay, I'm substituting it here. Now it is 1. 1 minus, I'm substituting 1, so it will be -6 plus 11 minus 6. When you total it, what you are getting? It is equal to 0. Okay, so 1 is the root. So now we have found out lambda is equal to 1 is one of the root. Now again you have to find out more two roots. Okay, we have got this equation lambda square minus 5 lambda plus 6. Okay, so this how you will solve. You know how to solve your quadratic equation. Solve it. You need to solve it in such a way that you have 6. Tell me. See, when you multiply, what you have to get? When you multiply, you have to get 6. When you add or subtract, you have to get -5. Okay. So what if you multiply 3 into 2? Okay. When you multiply 3 into 2, you will get 6. But you have to get a negative sign. So what you can do? Minus into minus. So -3 into -2 will become +6. And when you add it, -3 minus this, you'll get me. So when you write it, how you will write? Lambda square minus this 5 lambda only, we have expanded like this. -3 lambda minus 2 lambda plus 6 equal to 0. Okay, so what is common in this both? I'll take lambda outside, so it will be lambda -3. And what is common in both? -2 is common. So lambda -2, I have taken it outside, so you'll have only lambda. And from here, it will be -3 equal to 0.
Okay. Now, in both the terms, lambda minus 3 is common. So, lambda minus 3, I will take it outside. You will be left out with your lambda minus 2 is equal to 0. So, we have got lambda minus 3 into lambda minus 2 equal to 0. So, other two lambda here will become lambda is equal to 3 will be one of the root and lambda is equal to 2 will be another root. Okay. So this is how you will solve the equation. So we have got a equation with power 3. Okay. So you can't directly do it. So instead of doing it in your long division, I've done it with your synthetic division. Here in the value 1 itself, it got satisfied and you got that lambda is equal to 1 is one of the root. After that, the remaining values, you will write the equation. For that equation, solve that equation, get your other eigenvalues. Okay. Any doubts you've got? Write it down. So your eigenvalues, you will write the after you finish writing. The eigenvalues are 1, 2, and 3. Write it down.